Hello friend, in this video I will discuss a most important topic of physics, that is uniform and non-uniform motion, which is important for all academic exams from class 9 to 12 as well as most of the competitive exams. Okay, and after that we will discuss the concept of average velocity and average speed. So first we discuss the uniform motion. So in terms of velocity, uniform motion is defined as it is nothing but if the velocity of an object is constant during the motion, then the motion is called uniform. In terms of velocity, if you talk about in terms of acceleration, it is clear that if velocity is constant, that means the differentiation of velocity with respect to time is zero. That means difference in velocity and difference in time, which is gives the acceleration, which is zero. So in uniform motion, acceleration during the motion remain constant, which is the ratio of delta v upon delta t. That means acceleration is what? The change in velocity with respect to time is acceleration. If the velocity is constant, then acceleration must be zero. In terms of displacement, if an object covers equal distance in equal interval of time, then the motion is called uniform. So in terms of displacement, which is the product of velocity and time, we can define equal distance with equal interval of time. If the object covered, then the motion is uniform. If you talk about non-uniform motion, in this type of motion velocity varies with respect to time. If velocity varies uniformly, that means acceleration is constant or acceleration is zero. And in second, non-uniformly, if velocity varies non-uniformly, that means acceleration is not fixed. Sometimes accelerated, sometimes deaccelerated, means body slow down. So in terms of displacement, we can define the motion in which an object covers on unequal distance or displacement with equal interval of time, or we can also say the object cover equal displacement with unequal interval of time, then this type of motion is called non-uniform motion. We can also see and explain with the help of graph. In uniform motion, in VT graph the acceleration is zero. That means VT graph represents blank graph. Okay, in uniform motion, velocity time graph is blank because acceleration is zero, so the terms of acceleration is not present here. And from VT graph we can obtain two things. If we take slope of the object, if we take slope of the motion, we'll get the acceleration of the object, which is equal to delta v upon delta t. And if you take area under curve, okay, if there is area under curve like this, velocity or velocity constant, then this area represents the displacement of the object. And the second one is acceleration time graph. Slope of acceleration time graph, whether it is uniform or non-uniform, gives the jerk, which is the rate change of acceleration. And if you take area of under this curve, we will get the change in velocity. And finally, ST graph, the slope of this graph gives the velocity of an object, which is the ratio of delta s upon delta t. And similarly, we can say non-uniform motion VT graph, we also get the slope from this graph. If we take the slope of this object, we will get the acceleration. Okay, acceleration is nothing but delta v upon delta t. Change in velocity with this respect to time gives the acceleration. So if you take this slope of this graph, you will get acceleration. And if you find the area under curve, that means this area or whether this area. Okay, so this area represents change in velocity. Okay, in acceleration time graph, area, this gives the displacement of the object. In AT graph, what we say, for uniformly accelerated motion, there are two things. First one is uniformly accelerated motion, that means acceleration is constant, and second one is non-uniformly accelerated or deaccelerated motion. So this is the curve of uniformly accelerated motion, and dotted line represents the uniformly non-uniformly or accelerated or deaccelerated motion. So in VT graph, we can, if we find the slope of the curve, we will get the acceleration. If we find the area under curve, we will get the displacement. In AT graph, if we want to find the slope, we will get what? We will get jerk, which is nothing but the rate change of acceleration. And if you find the area under curve, whether this is dotted or this is plane curve. Okay, we'll get, if we find area, we'll get change in velocity. In ST graph we can see slope of this graph gives the displacement, slope of this graph gives the velocity, that means delta S upon delta t, and area under curve gives nothing. Okay, so this is uniformly accelerated motion, and this dotted line represents the non-uniformly accelerated or deaccelerated motion. So this is all about in this video. Thanks for watching. Thank you so much.